Greetings of the day. Myself, Dr. Ugrabadi Sahoo, and I'm working as assistant professor in the Department of Chemistry, MITS. And today I'm going to discuss about photocatalysis and its application in environmental and energy applications. Basically, this is the flow of my presentations. I want to discuss about introduction to environment and energy crisis. Then I'll discuss about photocatalysis. Then what is the applications of photocatalysis in terms of environmental and energy crisis? Then of course summary is there and a reference. Next, coming to the introduction part regarding environment and energy crisis, due to rapid industrialization and rapid population growth, about 84% of world's energy demand is depending on fossil fuels. That is why fossil fuel is getting depleting day by day, which causes serious kind of environmental pollution and global warming. That means eventually we can say due to rapid industrialization and human population growth, it is the main reason for environmental and energy crisis. Coming to water pollution, of course, the reason is very same due to rapid industrialization, or more specifically, I can say uh, agricultural sector, paper and pulp industry, uh, and these are the industries which are highly responsible for water pollutions. And due to the water pollutions, if we drink the polluted water, we can have some serious kind of diseases. Like I've mentioned here, we can see cholera, chlamydia, hepatitis A, diarrhea, and typhoid. That is why we need to have a potential candidate which can mitigate the global environment and energy crisis. We can see in the pie chart actually, it is being for the energy consumption, we are depending on a lot of renewable energy sources. That is why we need to have a potential candidate which can mitigate all the global energy crisis, and we can have a hydrogen as a sustainable source of energy which can mitigate the global energy challenges. Now question arises, why hydrogen? Because it has an excellent energy carrier, it is a clean fuel with zero greenhouse emissions, it is economically highly competitive, it is, of course, it is low cost, and it has a faster refueling time than other battery vehicles. That is why we can go for hydrogen as a potential source to mitigate the global energy crisis. Now, coming to photocatalysis. Photocatalysis is a process when light falls upon a material, the electrons are excited from valence band to the conduction band. Now, the electrons present in the conduction band are responsible for the reduction process, whereas the holes present in the valence band are responsible for the oxidation process. So basically, we can say photocatalysis is a process which provides both oxidation and redox reactions, and we can achieve significant photocatalytic applications with the process of photocatalysis. Different type of photocatalysis are there. Nowadays researchers are going for traditional semiconductor based photocatalysis, quantum dot based photocatalysis, two-dimensional material based photocatalysis, like we can say graphene oxide, Gc3 and 4 and all. And coming to plasmonic metal based photocatalysis is also there, and metal organic framework based photocatalysis are also there. But we are mainly dealing with metal organic framework based photocatalysis. As I mentioned here, different metal source can be used for the synthesis of metal organic framework, like iron, cobalt, copper, nickel, etc. And we can see here metal organic frameworks are a three-dimensional network structure. You can see the yellow balls are there, these are the metal sources, and the red lines, these are the ligand sources. That means metal organic framework is a three-dimensional structure in which the metal sources are interconnected by means of ligands. Different applications can be achieved by the help of metal organic frameworks, like drug storage, separation, purification, sensor, and gas storage. And at last, we can say catalytic applications we can achieve through the help of metal organic framework. So nowadays, catalytic applications with the help of metal organic framework has been researched to a significant extent. Basically, metal organic frameworks can be used as a photocatalytic system for the dye degradation process. As we know, Beer-Lambert's law suggests that the absorbance is equals to epsilon C BC, right? So absorbance is directly proportional to concentration. Suppose we have any colored solutions. Here I'm taking rhodamine B as a indicator solutions, or as is example. So basically, when I introduce photocatalysis with the help of metal organic framework, during the time like 15 minute, 30 minute, 45 minute I mentioned here, and we can see the change in color it is there. That means we know that the observance is directly proportional to concentration. So down the time, the concentration of the rhodamine B is getting decreased, and we can see through the UV graph. Like 45 minutes, the concentration is pretty much lower. We can say it is almost zero. Therefore, we'll get very low observance spectra for rhodamine B. So in this way, we can use metal organic frameworks for the photocatalytic dye degradation process. And coming to a hydrogen evolution process, I have taken the photograph of a hydrogen evolution setup. We can use metal organic framework for the photocatalytic hydrogen evolution process. Like we can generate some hydrogen gases through the water splitting. Basically, if water is getting splitted, it will eventually form hydrogen and oxygen, and if we put a oxygen scavenger, then only gas it will produce, that is hydrogen. In summary, photocatalysis leverages light activated catalysis to degrade the pollutants like bisphenol A, pesticides, breaking down them into harmless compounds, thus mitigating environmental contaminations. Then photocatalytic system facilitate actually water splitting, by which water is getting splitted to produce green and sustainable hydrogen, which can address the global energy demands. And of course, photocatalytic system offers a versatile platform for addressing environmental and energy challenges simultaneously, such as pollutant remediation and hydrogen evolution. Photocatalytic technologies have the potential for a large scale applications due to their resilience on abundant solar energy and cost effective materials, promoting sustainable environment and energy solutions. So these are the references, and if you have any queries, you can fill the Google form here for your feedback. Thank you, sir.